Two or more functions in math are said to be linearly dependent if one of the functions can be multiplied by a scalar to produce the other. Now, take for instance, I have y1 equals x and I have y2 equals 2x. So you can see that y1 was multiplied by 2 to produce y2. So I can actually say that y2, which is the second function, is 2 of y1 because I multiply y1 by 2 to produce y2. So in this case, we say that both y1 and y2 are linearly dependent. Now, if there is no scalar that can multiply the first function to produce the second function, then we say that those functions are linearly independent. Take for instance, I have y1 equals sine x and I have y2 to be cos x. Now, these functions are not linearly dependent, they are tend to be independent functions because there's no scalar that can multiply sine x to produce cos x. Given set of functions, say y1 of x, y2 of x, y3 of x, down to yn of x, the Wronskian of this set can be defined as this w y1 of x, y2 of x, y3 of x, down to yn of x. Now, this is defined as a matrix of the derivative of each of these functions down to n minus 1. So this goes like this. I have a very long matrix, y1 of x, y2 of x, y3 of x, down to yn of x. So this is going to take the first derivative of y1 of x, which is y prime 1 of x, y prime 2 of x, or y3 prime of x, down to y prime n of x. We will continue this matrix down to yn minus 1, 1 of x, yn minus 1, 2 of x, yn minus 1, 3 of x, down to yn minus 1 of n of x. So this determinant matrix is giving us the Wronskian of this set of functions. Now, once the Wronskian test is equal to 0, then the functions tend to be linearly dependent. But if the Wronskian test is not equal to 0, then the functions are said to be independent and vice versa. In this example, we will show that these two functions are linearly dependent or not. So we are going to apply the Wronskian test. So let's apply the Wronskian test, w of x squared and 2x squared. Because I have two functions there, I expect the determinant of a square matrix of these two functions and their derivatives. So this goes like this, x squared and 2x squared. Now their derivative is going to be, derivative of this is 2x and the derivative of this is 4x. So if I should apply that, this looks like x squared multiplying 4x minus 2x multiplying 2x squared. So this is going to be 4x to the power of 3 minus 4x to the power of 3, which is equal to 0. Now, since the Wronskian is 0, we say that the functions are linearly dependent. In this example, we show that these functions are linearly independent or dependent. So we have the Wronskian of x and sine x to be the determinant of the square matrix of the functions first, which is x and sine x and its derivatives. So the derivative of x is 1, derivative of sine x is cos x, making it a 2 by 2 matrix. So now I will apply the determinant, of which the determinant can be given as x cos x minus sin x. Now you can see that this determinant is not equal to 0, so the functions are linearly independent. So we are going to prove if these functions are linearly dependent or not using the Wronskian principle. So we are going to apply the Wronskian of exponential x, exponential minus x, and exponential minus 2x, and that gives us the determinant of a 3 by 3 matrix, which includes these functions first: exponential x, exponential of minus x, and exponential of minus 2x, and their corresponding derivatives, which goes this way. Derivative of exponential x is exponential x, and derivative of exponential minus x is minus exponential minus x, and the derivative of exponential minus 2x is minus 2 exponential minus 2x. Now if I go again, I should have this to be that the derivative of exponential x is exponential x. The derivative of minus exponential minus x gives you exponential of minus x because the negative signs clashes. And coming down here, we are going to have 4 exponential of minus 2x because the negative sign. So we are going to find the determinant of this now using Sarah's method by taking first the right indented, then the left indented. So going with the right indented, I have exponential of x multiplying this and multiplying that, which is minus exponential of minus x, and 4 exponential of minus 2x. Now coming down here, this, then hitting this, I have a plus exponential of minus x multiplying this, which is minus 2 exponential of minus 2x. Now multiplying this, which is exponential of x. Now plus, finally I have this exponential of minus 2x multiplying this first, which is exponential of x. Now multiplying exponential of minus x. That's for the right indent. Left indent, we have this multiplying the left indent, which is exponential of x. I will separate the right indent from the left indent with a negative, and I will see use a squared bracket. So I have exponential of x multiplying the left indent, which goes as minus 2 exponential of minus 2x, which is this multiplying this guy here, which is exponential of minus x. Now plus, I have exponential of minus x multiplying the left indent, which goes this way now as exponential of x multiplying 4 exponential of minus 2x. And lastly, we have plus exponential of minus 2x multiplying this, which is minus exponential of minus x and multiplying exponential of x. In opening this, I will apply a bit of indices because of the powers of the exponentials, and I will also take note of my coefficients, which is the negatives and the scalars. So this goes like this as minus 4, which is still in brackets, minus 4 because of this. Now x minus x is gone, and I have only exponential of minus 2x surviving. Now let's come to this place. Because of this negative, this automatically changes to negative 2 exponential. Now I have minus x minus 2x is going to give me about minus 3x plus x, which is minus 2x. Now plus, I come in here, I should have exponential minus 2x minus x, which is minus x. So I have minus x again, which gives me about exponential of minus 2x. Coming down for the left indent, I have this negative here, and what I still have inside this place, I have a negative here as well, which is negative 2 as the coefficient. Now x minus 2x is a minus x and minus x again, which gives you minus 2x as the power of the exponential. Now, coming down here, I should have a plus 4 because of this. Now, minus x plus x is gone, and I have only exponential minus 2x surviving. Now, because of this negative, this changes to negative now, and I have exponential of minus 2x minus x is minus 3x plus x is minus 2x. You can see that this looks like minus 4 exponential of minus 2x minus 2 exponential minus 2x plus exponential of minus 2x minus minus is plus 2 exponential of minus 2x minus 4 exponential of minus 2x and a plus because of this exponential of minus 2x. Moving on, we have minus 4 exponential of minus 2x and minus 4 exponential of minus 2x, which gives us minus 8 exponential of minus 2x. Now I have a minus 2 exponential and a plus 2, so this cancels out. Now I have exponential of minus 2x plus exponential of minus 2x, which gives me plus 2 exponential of minus 2x. So this is minus 6 exponential of minus 2x, which is not equal to 0. So we can say that the functions are linearly independent.